Good afternoon, everyone, and welcome to the Parsons Technical Webinar Series. I'll be your host today, Jessica Bennett. Today we have with us Carrie Crozier, Chris O'Neill, and Buffy Quinn, who will be presenting on managing complex environmental sites, advances in data management, client engagement, and community participation. Next slide, please. So a few housekeeping items up front. We'll be keeping all phone lines muted during the presentation to keep any background noise down. If you have any questions, you can either ask them at the end of the webinar during the Q&A session, or you can enter them into the chat feature at any time, and then we'll answer them at the end. This webinar has been approved for 1 professional development hour or PDH credit. If you'd like to receive a certificate for that PDH credit, there will be a link to the attendance form that will be posted in the chat. There will be 4 multiple choice questions that you'll need to answer, so please take a look at those at the front of the presentation. And I will also post those in the chat if you have any issue getting to that link. If you have any issues downloading the form, you can also just reach out to us after the webinar and we'll get that form to you. And you can also email daniela.savin@parsons.com for that. And finally, this webinar is being recorded and will be available on the Parsons YouTube channel in the next few days. So a brief agenda for the presentation. We will be going, I will introduce the guest speakers briefly, followed by a core value moment. We'll get into the technical presentation, and then we'll wrap up at the end with a question and answer session. So a little bit about our presenters today. First off with Carrie Crozier. She's a project manager who specializes in data management and analysis of complex data sets. She's also a professional geologist. Chris O'Neill, he's a principal GIS specialist and is a GIS lead at Parsons, focusing on data management and visualization, and he's also an avid data science enthusiast. And finally, Buffy Quinn, she is a project manager with us who specializes in GIS, data visualization, and community outreach. And with that, I will hand it off to Carrie for the core value moment.
Thanks, Jess. Happy to be here. We like to start all of our technical webinars off talking about the 6 core Parsons values: safety, quality, integrity, diversity, innovation, and sustainability. And a lot of the data management topics that we're going to be discussing today really touch on all 6 of these, but I'm going to focus on innovation for today. The Parsons data management team loves to combine our existing tools, and we also develop and build new custom tools that allow us to create new processes and develop unique solutions to help our customers solve problems. We really have the goal of helping our clients interact with their data in a different way than they've been able to do before. Next slide, please. Okay, an agenda on the technical topics we'll be covering today. I'm going to be starting off with some kind of data management concepts up front, things to think about when you're encountering some complex data sets. And then we'll give you several case studies, and then we'll wrap up with how we leverage different systems and a little bit on how data science comes into play. Next slide, please. Thanks. Okay, so what do we need to think about when we are talking about complex data sets and data management? We start by asking 3 questions. The first is, what kinds of data are going to be collected? We want to know where it's coming from, what it's going to look like, and how much we're going to be receiving. The second thing we'll think about is who's going to be using the data. How do they need to interact with it, and what does it need to look like for it to be useful for them? And finally, cost benefit. There are a lot of really great tools out there that can automate a lot of data management, but they take some setup. So we need to think about what the right amount of data management is for a different set of data. Next slide. So this is kind of a data flow through a typical remediation project with all of our inputs coming out on the left, moving through our data management system, and then coming out on the right. So typical remediation projects have a couple of different sources of data. We have a lot of data that comes in from the field. We have a lot of data that comes in from the lab, and we also get a fair amount of data from other sources. This may be your remediation compound. If it's connected to Wi-Fi, can pass data to you. It might be historical data, data from sites nearby, or even other data warehouses like EM-Equus or in California, the GeoTracker database. So we bring all this data in to one place, and then we can do things with it. There's two different ways we can look at the data. One is a deliverable. This is static. It's going to look the same 2 weeks from today as it looks right now. So that might be a daily log, a technical report, a table, or an EDD or electronic data deliverable. These we make once, they look the same. The other thing we can do is build a dashboard. This gives us a live look at the data. This is really handy when you have long ongoing projects or projects that have really dynamic decisions that need to be made. So they look very different 2 weeks from now than they look today. And we can set these dashboards up to display a lot of different information types. You can have tables, graphs. The GIS is Geographic Information System. This is typically mapping. We can also set dashboards up to create automated alerts. So if you have a trend at your remediation compound heading towards a compliance point in the wrong direction, it can automatically email your technicians, your project manager, and say, hey, there's a problem developing over here. Send someone out right away. Next slide, please. So revisiting those three questions, we're going to dive in a little bit deeper on each of those three. The first was, what types of data are you collecting? We do have a lot of people collecting data on mobile forms. The tendency with this is to really load up the field form and make sure you're getting all kinds of data that maybe you never were able to capture before. As you can see with my colleague up here on the right, this is up in northern Canada in January. It's very cold. It's very dark. We still need to collect compliance parameters. We don't want our field team out in these kind of conditions longer than they need to be, particularly if they're collecting data that no one's ever going to look at. So we really want to make sure we're being very careful about the design of those forms. We can also connect directly to the laboratory information management systems, or LIMS systems. If you work with a lab closely, you probably hear that phrase a lot. We can connect to those using SQL servers. And that way, as data is approved by the lab, it can flow directly into our data management system. We also have telemetry from the Internet of Things, and this is kind of a catch-all term for anything that connects to Wi-Fi can pass data to a SQL server. So it might be remediation level loggers, it could be weather stations, all kinds of things that connect to Wi-Fi can pass us interesting data. And finally, there's external databases. GIS, which I mentioned before, EAM and Equus are two data warehouse softwares that a lot of our clients use. And then CRM is cost recovery management tools. We can also connect to safety databases and things like that, all automatically, so that the data flows from the field directly to these places. We need to think about how we're going to store and access this data. So databases are great for lab data and measurements, numbers and text, but they're terrible for photos. We also think about web portals. If we need to pass data to people outside of Parsons, we will typically set up a web portal that allows people from various organizations to come in, grab their data, and interact with it if need be. Document management systems can be really key. We have some projects that generate thousands upon thousands of documents. We need to make sure those are organized and easy to find. And then, do we have a spatial component to this data? That's the geographic information systems. And just a reminder, just because you can collect data doesn't mean you should. A lot of tools that are out there that are Wi-Fi enabled can pass data as frequently as once per second. We have a fair number of weather stations that are able to report weather once per second. We don't want that much data. It's a huge pain to manage and store. So we need to think about how much data we can actually process. Some of our tools do start to malfunction when we overload them with too much data. So we think about the amount is really critical. Next slide, please. Okay, the second question was, who's going to use the data and what do they need it to look like? So you need to know, how tech savvy are your users? You have a lot of folks who aren't normally sitting in front of computers every day that need to be interacting with your data. What do you need to make it look like so it's understandable for them? You also need to understand whether your field team is going to have uninterrupted internet access or whether they even really need it. You need to pass real-time data back and forth between the field and the office, or is your project one where you can collect data, wait for it to come in, evaluate it in the office, and then go back up for a second round? It's critical to understand what the data needs to look like in order for the team to make decisions. Tables, trend graphs, and spatial data are our most common ways that we display things. And finally, how are we going to be communicating within the project team? For some projects that are very fast moving, we need the data to flow from the field to the office. the office team can get on a call with the regulator and client. We can make decisions while the team's still working in the field and say, okay, now we need to step out in this direction, go ahead and get moving in that direction. Other times we do, once a week or even once a month call to look at the data together and then make decisions. So it's not as critical to move that left. Next slide, please. And finally, cost benefit. There is some cost associated with data management. One is hardware. Everyone on the team needs to understand who owns the hardware at the end of the project before you make that purchase. Also, software has licensing fees. It can be really variable depending on what your data needs are. So it's important to understand what those cost implications are before you start building your tools. And then you're probably going to need someone to build and maintain your database, both while the data is being collected and over time as the project evolves. And finally, there may be some external data sources that you need, and we'll give some examples of those today. There are a lot of cost benefits, though, from smart data management. One is we really like to work to reduce data entry errors by making sure the data only ever has to be typed in once, often in the field. So we do push data from the field into our data management system. It can feed the text, the tables, and the figures, all without having to be retyped by anyone. We build QA/QC so that folks in the field are aware if their data looks strange as they're typing it in. It's really easy to miss a decimal point or mistype something in the field. So on our field forms, we have them set up. If you're taking a well level, our field forms can know what the expected range of water, depth of water measurements would be for that well. And if you type in a number that's outside of that, you get a little alert that says, hey, this is out of the expected range. Double check your tape. They can make sure they haven't put in a typo. They can double check their tape. Maybe it really is out of range, and that's fine. But if not, they can correct it right while they're in the field. And then this allows us to make decisions while the team is still in the field if we have uninterrupted internet access for the field team. And because the data is coming in directly from the field and it's easy to QC, we can really speed up reporting and reduce labor costs. Next slide, please. Okay, on to the case studies. The first one is on rapid decision making. So we have a very large mine reclamation site in northern Canada. It's about 9 square miles, and we have a groundwater capture and water treatment system up there. It's multiple locations across this facility. We run it 365 days a year, 24 hours a day. So this is a constantly moving data collection source. There's a lot of different types of data that get collected at this site. It is a very remote site. So we actually have water quality data that gets run by an on-site lab. We have environmental data, we have water train operational data, and up here weather is really critical to know. So we have a lot of weather station data. We do have multiple stakeholders, both on and off site, that need access to this data. In order to stay compliant, we need to look at it as it's coming in to really understand what's happening with the water and get ahead of any changes before they become compliance issues. As I mentioned, it's really remote. We do have a limited cellular network up here, but we have really good Wi-Fi at this site. So what we've done is we've been able to run Wi-Fi repeaters out to each water treatment plant, which is where the bulk of the data at this site is collected. So we do have connectivity while they're at the treatment plants. When they're driving around site, they have an offline mode, and as they drive to a water treatment plant, their tablets will kind of reconnect and catch up on the data and update any data pushes that have happened while they've been offline. We do have extreme weather up here, down to -40, and limited light in the winter. It took us a while to find some really rugged tablets that work in this condition, but we were able to figure it out. The data needs for this project were a way to see water quality alerts and trends faster than looking at on tables. They were having to wait for technicians to get back in, type in data, and then it would have to be reviewed in a spreadsheet. And then we wanted to look at where we were moving water and see the weather tracking. Next slide. I'll show you what we built. Okay, so this is a map. This is dummy data. I wanted to show what it would look like if there was a problem. Our mine manager can now open up the map of all the compliance sampling points, and there's a variety of different views for this. But if there's a problem, they're going to see a bright color. If everything's gray, they know they're having a good day and everything's in compliance. If they've got a problem, It's going to show up bright red. It's easy for them to say, okay, this is where we have a problem, and they can send a technician out right away. Next slide. They can also click on any one of those points and pull up a whole bunch of different types of data. In this case, we're pulling up total discharge for that compliance point. We can look at accumulative and minute by minute discharge for that point. Next slide. And then we can pull up data for multiple points. So if we're making a change in the treatment train and we need to make sure it's having the intended effect, we can pull up multiple points and compare and say upstream of our treatment point, this is the concentration. Downstream, we have a different concentration. And we're using Power BI to do all this. This has been a really great cost savings for this project. It's a lot less labor intensive. Everything, again, only gets typed in once, so we don't have to retype it into a bunch of different places. It speeds up the reporting and makes it much easier for the mine managers to see what's going on. They don't have to dig through a pile of spreadsheets every morning. Next slide. The next one is on automated reporting. So we have a site where we are doing residential cleanups for some soil that's impacted with lead. We did about 750 of these properties in about 2 years. And the way the cost structure was set up for this project, we had to do an individual work plan and an individual closure report for each property. And as you can imagine, doing 750 properties in 2 years, we had a lot of crews working at one time. So we had more than 20 crews writing work plans in any 1 week. We're writing 20 work plans. We were in construction on 20 different sites, and we were writing closure reports for another 20 sites. So there's a lot of moving parts on this project. And the way we kept ourselves organized were the text, figures, tables, and appendices were really tightly controlled and standardized. And we built an automated reporting system that generated a lot of this for us. Next slide, please. Okay, so what we did, and this is again one of those flow diagrams with all the data coming in on the left and moving through to the right. We gathered as much of the data as we could on tablets, and we did have an ability to pass maps back and forth between the field team and the office-based GIS team, so that throughout the day, as maps were being adjusted, we could pass that data back and forth. No one had to come back to the office and print and scan maps. It was all pushed back and forth from the field. We would also collect photos and daily field notes on those tablets. Those would get generated into PDFs that were used as appendices in our completion reports. And a lot of the data collected in the field was also inserted into a SQL database, which was, again, put in the text, the tables, and figures, all from one data entry point. We used SharePoint to store all of our different documents. And for the documents that came in when we were out of the field, things like the waste manifest signed by the landfill, those would come in as PDFs. And when we would upload them to SharePoint, we would tag them with metadata. So we knew what site each document was for. And for something like a manifest, we would do the destination landfill and the total tons of waste shipped. So from that metadata tied to that document, we could make sure that everything lined up correctly, again, in the text, figures, tables, and appendices. And then finally, we used Power Automate, which is a Microsoft tool. And it would grab all of those different documents from our SharePoint site and put them in order and generate a bookmarked PDF of all the appendices. And these were quite significant, as thick as an old phone book kind of packages at the end of the project. So the cost break-even point for this was about 200 properties. So it was a significant setup to set this whole system up. But because we did 750 properties, this was a significant savings for this client. Now I'm going to pass it to Buffy for the next case study.
Thank you, Carrie. So, Chris, if you want to go ahead to the next slide, that's fine. I'll talk a little bit about client engagement. Carrie mentioned that knowing your stakeholders is an important consideration when you're creating your data management strategy. And an important stakeholder to consider is our clients. And Carrie also introduced the topic of digital dashboards, and those can be developed for the specific needs of a project. And they can help promote project success because if we can share the data with our clients and our internal project teams, that allows for more collaborative work, and it helps us address any issues or concern as they arise. And that promotes communications and good client relations. So Parsons is providing third-party oversight for the New York State Department of Environmental Conservation at a site where the remedy consists of removing impacted soil at 326 individual residential properties and then replacing the top 2 feet of the cover system. So for this project, Parsons built a digital dashboard to make it easier for our internal team and the client to keep up with the schedules, track action items, track property owner complaints, access project files, and assess the status of cleanup and restoration work at each property and for the project as a whole. The data that serve that dashboard come from Forms on Fire, GIS feature classes, Equus data results, SQL databases, and SharePoint lists. The Power BI dashboard is set up to allow different people different sign-in and access depending on what they need to view or edit. Some users have access to our analytical database and GIS files. Others have access only to certain folders or files. And Chris is going to talk a little bit more about that in a bit. Next slide, please. This is the landing page for that digital dashboard. This map image is pulling from our GIS data, and the status of the remedy of each property is stored in the Equus database. And each property, that's each parcel here, has a unique ID that corresponds to the database and the GIS files. So this setup allows the client to search for a parcel by name and see the analytical information attached to it. Next slide, please. This screen grab shows how the analytical database can be linked to the dashboard as well. So in this example, on the right side of the screen, you can see that the chemical of concern is SVOCs. Properties where any of those values exceed the requirements are displayed with the red dot. So the data are housed in Equus and GIS, but the query is performed in the dashboard. Next slide, please. So just as with a GIS, the user can view the data as a data table rather than on a map. This screen grab illustrates the data associated with each of those red dots. Next slide. The dashboard also provides access beyond what is in the GIS. So this screen grab shows how the team can keep up with action items and due dates. So if you see that category window on the right, those check boxes are really search terms, that is slicers in the Power BI world, that allow the user to focus on just those categories that are important to them. Next slide. This screenshot illustrates the weekly action item tracking sheet. With so many reports, letters, and inspections, the dashboard helps keep everyone on schedule. Next slide. And just as Carrie illustrated before, this dashboard also offers different ways of visualizing the data. Graphs can help users see both temporal and spatial trends. Next slide. We've also added an app to the dashboard that uses satellite data that we purchased as a subscription service from an external supplier. Next slide. That satellite data is in the form of imagery that we can use to detect change in land cover health using what's called the Normalized Difference Vegetation Index, or the NDVI. And this can help identify where vegetation is healthy versus where it's struggling. This kind of imagery is typically used in agricultural settings to assess crop health, but we're using it to detect changes in the 2-foot cover system on the project. For instance, if the cover's been replaced on the property, this app can help users see where new sod may not have taken hold and needs to be further inspected. We're currently adding historical digitized maps into the system where we can see changes over time. We'll be comparing Sanborn fire insurance maps with current land use. And Chris is going to demonstrate this slider for you in just a bit. Next slide, please. So the public is often a stakeholder for our projects, and it's important to be able to reach out to them and give them avenues for contacting the agencies or the project teams. So we wanted a way to convey information in a 1,000 plus page site management plan that is of specific importance to property owners and the general public. So the New York State Department of Environmental Conservation asked if we could do something to help the public understand and access this very technical and very long document. And they also suggested that they would like something that could be easy to use, like an app that you could use on your phone. So we used an Esri ArcGIS online app to build a story map. And Chris is going to talk a little bit about ArcGIS Online in just a minute, but the story map that we developed can pull in GIS data, links to other sites, such as the client's website, videos, images, and text to help tell a complicated story in a really accessible way. So the app we developed provides contact information, has an FAQ section, includes information important to property owners, and explains the entire site management plan's more complicated technical information for a lay audience. So on this slide across the top are some screen captures of what the app looks like on a smartphone. And then on the bottom, that's what it would look like on a tablet. Users can easily move through the story map by simply scrolling from top to bottom or use the links at the top to jump to a particular section. The story map is now public, and if you want to grab that QR code, you can take a look at it for yourself, of course, after the presentation is over. So let's see, Chris, I think I'm going to jump to you now.
All right, cool. Thanks. I'm going to talk a little bit about kind of a case study for spatial data, really what the GIS end of things look like here, and talk really briefly kind of in a bird's eye view of the platforms that we're using and how we're leveraging these systems, and then just kind of touch a little bit about data science. It's kind of a really broad term. So our use of the term complex and managing complex environmental sites is it's intentional, right? This particular site is one where it's a management of a residential drinking water sampling program in a rural part of the country, and it started out as a few sample locations at a discrete site that measured about 2,000 acres. And really over the course of several years, the area of concern over which we were managing data grew to encompass an 8-county area of about 6,400 square miles. That's a spatial increase of about 3 orders of magnitude. We're responsible for determining who is on private drinking water sources, that is, who had wells, who was on public water, and then offering sampling to those residents who qualified under the compliance plan for that. And this project comprises now about 295,000 records. Each one of those records are essentially residents where we are now managing numerous metrics that need to be tracked. And the way in which we manage this type of data is really through really leveraging mobile data collection platforms like Forms on Fire connected to a GIS backend and other SQL databases and other automated data management procedures. So specifically, the types of GIS data management that we used was the Esri suite of software, and things we were looking to answer were where to sample. We needed to be sure that we allocated field resources appropriately. Knowing where we had been and where we still needed to go was an important thing to know. We also needed to resample some residences quarterly, so knowing information about sample counts and stuff was really important. And for our stakeholders and project management team, they really needed to know at a glance where and what type of constituent exceedances we were dealing with. And thirdly, we also needed to understand the potential potential folks that still needed sampling. What was their distribution? You know, there's a way by which you need to sample these. You can't just pick out a group of points and just go there. And this operates on a linear network of roads that get you from point A to point B. So we quickly realized that we really had a vehicle fleet management issue to be dealt with. What you're looking at here is a software service with an app front end and back end that we use called Optimo Route. You know, last year we had 15 teams driving about 150 miles a day, 5 days a week, 52 weeks a year. You add in other miles from safety, management, and other investigation tasks, and you arrive at about 850,000 miles a year. Driving is the most dangerous thing that we do. We not only wanted to reduce risk of exposure on the road, but we also wanted to decrease our carbon footprint. So using this service allowed us to utilize kind of, you know, network intelligence to get us and our resources to the proper places to do it safely and quickly. Adam Westcount's one of our GIS team members on this project. He really served as a dispatcher. He worked remotely, working with our call team to make sure that all of our clients had been served with sampling and water deliveries and such. So, you know, just really just a few examples there of how, you know, kind of the what we're doing, and all of this, you know, the systems and the interconnectivity is really built on other data management systems. There's many out there, right? One of the things that we need to ask ourselves, though, before we launch into what types of system we're going to leverage, and Carrie touched on this a bit, but it bears repeating, right, is what types of data are being managed. You know, the geospatial data, analytical data, field data, ancillary data. You know, in what form are we ingesting it in? Is it derivative data? And what type of privacy or security issues are we dealing with around this data? Are there any hold order data? Like what are the potential exposure points? So, you know, all things to consider when picking, you know, a data management system, or really a hybrid data management system, which is essentially what we arrive at a lot of the times. And it seems that you know, every data management platform kind of advertises itself as like the one-stop shop for like all your data needs. But one of the things that they really have in common is this kind of centralized data location with different entry points for different subject matter experts. You know, we leverage Power BI for our dashboarding system. This is Taylor Schweigel's realm. She is kind of our subject matter expert here. Power Automate and Power Apps. This is Jennifer Trim's Cordis Sandbox, you know, her entry point for really managing these data that interact with data that can be centrally located. I know that Microsoft Power Platform advertises their Dataverse as the one repository for all of this. And Parsons, I'm highlighting Microsoft Power Platform because Parsons really has recently acquired a lot more premium licenses around this. We're really looking to leverage this. In addition to that, you know, there's systems like Equus, right? And this is kind of Laura Drachenberg's expertise here, you know, and the same sort of scheme here where you've got a centrally located database with many different entry points to interact with these data. You'll notice down here in the bottom right hand corner that it does explicitly list Microsoft Power BI connector. That's also a commonality here in the ArcGIS world, that data connectivity with Power BI, although it's not listed. But again, a similar construct, right? You have different apps that allow us to collect, ingest, and interact with data around a centrally located database with all of these advertised functionalities around that. So what this really looks like from the back end, from Power BI, is kind of this. And So it's not like a really visually striking slide, but the point here is to point out that really all of these data that are highlighted here on the right hand side of this slide, in the majority of cases, these are live data and that are feeding into the backend dashboard that Taylor is customizing for the project teams and clients. I mean, it really is a system of systems kind of within its own system, right? So I mean, that's why we use this term, and it is a hybrid approach. So managing these data and the integrity of these data really require that we pay a lot of attention to detail. Carrie talked earlier about Forms on Fire and the benefits of that. And we do try to ensure data integrity from the beginning when we are ingesting these data into these systems. And you know, having ensuring data quality, make sure that further on down the processing stream, you don't have any type of procedures that just kind of puke and fail. So it's really important to maintain data integrity around this. Another thing that we use on a lot of these projects, and it's something that was introduced to me on another really large project that I showed earlier, is this whole concept of being meticulous about documenting metadata, you know, that is data about your data. Any table that lives in your system, what is its name? Is it clearly defined? Define all of the column names, the data types. What are the potential values that can live there? Are they confined to valid value lists or domains of data? And are those domains explicitly listed in your documentation like we show down here? These domains correspond to these different tabs down here. It's important to do this not only for auditing purposes for the programs themselves, but we don't know who is going to receive this data after years of use. You know, many times these projects are handed off to somebody else. Being able to document what you did and how it's defined is very important for the lifespan and handling these data. I did want to talk a little bit more specifically about a newer offering that we're seeing a lot more of and leveraging a lot more within Parsons for our AAC clients. And there's a real need for them and pressure on them to really you know, move forward digitally so that they can sort of experience all the benefits of a lot of the tools that are out there. And one of these newer systems is a project delivery system by Esri. It's essentially ArcGIS Online. And what we really like about this product is it allows us, you know, Parsons, to be stewards of the GIS data with all of the other connectivity to different systems that we've discussed here. That was the web map that Buffy showed, and the slider app. I'll show that in a minute as well. But we really like this because it allows a more kind of an interactive relationship with the data on behalf of the project team and the client. And it's just like it is its own deliverable. Like it goes with the client after our relationship has ended. Like it goes with them. It's its own thing, and it's really, really great. We're really excited about it. So like fitting all that together, that platform I was just speaking of, it can look something like this, right? Where we have at the bottom left-hand corner here, we have like an ArcGIS desktop user that does some sort of analysis. Those data can then be pushed up to the ArcGIS Online platform where you do things like manage your users and your groups and the different products that are hosted and originate from there and are created by the multiple users here. The scrolling graphic at the top, you'll see the story map that Buffy was talking about. We've got our splash page. We have, you know, different layers that show up and different hosted data that, you know, moving to the right clockwise here, you can see that these data feed into Power BI, the screenshots that Buffy showed earlier. That's this interface right here. I've intentionally left this blank to kind of drive home the aspect of the data security around this. If somebody were to land on this page, you still have to have your credentials for the GIS data that's managed over here. Those credentials are managed through this interaction. You would actually sign in on this page. It's once it's in your cookies in your browser, you don't have to sign in again, but your first time you do, right? But again, so pushing the GIS data that's hosted here into these other applications. And then there's other things, right, that just kind of live out in the wild on their own, given that you have the right credentials for them. So this is the app slider right here. It's not hosted. It's not viewable through Power BI. It's not a desktop thing. It's something that's created in this AGOL environment and then pushed out. And then users can interact with it. And so here's kind of what this looks like, right? And this is a web app builder. This is a custom app that we built for our client. And as Buffy was pointing out, it's got a neat little slider function. You can have trailing and leading imagery underneath this. So you can look at different different images or different raster data. There's some neat little other ways to interact with and customize kind of your viewing experience here. You can bookmark different things. You can preload this with different bookmarks for your audience. And one of the other things that I built into this is kind of the ability here to, you can search by Res ID, right? If we were to search for, let's type this in, Res 221, and hit enter, it'll go and shows me the address. This is reversible too. I mean, you can search by address and get Res ID. It's just something you kind of customize in here. And then you can always find your way back to the Power BI dashboard through Live Link. Kind of app summary here just kind of tells you like, well, what is this? What is this stuff all about? And how did we arrive at this thing? So some real interesting products that we can customize for our project teams and clients. Okay, so next slide here. So I kind of want to talk a little bit about data science. It's a really, really broad topic, right? So the process of data management, producing graphics, infographics, and visuals on kind of the scale that we're doing this means knowing how to extract meaning from data, how to interpret data. It requires the ability to really wrangle data and wield tools that are never as intuitive as they're advertised. So what do we mean when we use the term data science? So as one example is optical character recognition, or OCR. This particular example is one Empower Automate, where where we take advantage of Microsoft AI Builder to perform this OCR routine that is going from like handwritten notes and digitizing that and pushing it out to database. To a database table somewhere. It really eliminates the human error component with transcription, right? So we're currently working with Thomas Volker of Parsons Intelligent Automation Group on how to really embrace and utilize these tools properly within kind of a Parsons framework. That group's really, it's a cross-functional group of users and developers and really that are looking to enable automation across all areas of the Parsons organization. One of the other things that I wanted to speak to a little bit is kind of the a lot of us that kind of play with this stuff, even though it's advertised as low code, no code type things, like there are benefits to having coding experience. Because a lot of code, specifically Python, which is kind of a workhorse for data science, is embedded in a lot of different applications. It's embedded, it's got exposure points in ArcGIS. It's got exposure points for 3D modeling software that a lot of our teams use. And I think in the newest release of Excel, it's actually embedded as a ribbon option. The examples here I wanted to speak about is kind of a GIS-y implementation of this, where there's a specific type of sampling methodology that we're looking to use at a site, incremental sampling methodology. And the point here is to, between different decision units, that is these blue boxes right here, 9 and 10, to be able to replicate a randomized sampling scheme within each sampling footprint, that is these light blue boxes. So we've got circle, triangle, square, and you'll notice that the placement within the box of each one of these is exactly placed. Like you wouldn't do this manually. You wouldn't digitize these things with a mouse. Like this is something that you would script out. You can see kind of the same thing in decision unit 10 right here, where we've got, again, circle, square, triangle. The placement of those is a little bit different, but it's exactly replicated within each square within this decision unit. Another example in a 3D modeling world would be to we have like 10 years worth of chloride data for this site, and the project team's like, can we like build an animation that kind of scrolls through and shows each one of these shots for this plume as it kind of migrates around this site. And it's a little laborious, right? Because you have to within the software, there's a way that you capture each time period. Well, something like this, you can script this out. You have it run through the data and just kind of automate this for you, because when the request changes, and they often do, and you want to change the time period over which you're capturing data, you can then just go back to your script and run it again with different parameters. The last sort of Python example here is just kind of a scenario that came up early on in a project, and the issue here was, look, we've got this directory and it's got all this data in it, and embedded within each of the file names, like there's this unique identifier. You guys saw this earlier when Buffy was previewing the Power BI interface, so the unique IDs, right? These are unique IDs, this res numbers and EA numbers and such. And the thing that we were looking to do is like just grab everything with its unique identifier in the name and just put it in a folder all its own. So we have kind of a universe of data for all the communications around this one residence ID, whether it's a document file, messages, JPEGs, etc. So again, you just write a Python script that goes through and like recursively grabs everything and then makes its own folder, puts it in there, and that's really what initially had allowed for the interactivity with the Power BI dashboard. It's that places it in a SharePoint location that we can link to, instead of having to have Taylor have to like make all these different connections for every occurrence of this thing. So I know that next month there's going to be a lot more. There's going to be another presentation that really dives more into AI and how we're using it. But this kind of ends my segment here for the GIS case study and platforms and such. But the key takeaways that kind of wanted to leave our audience with here are things that we really tried to drive home, which is to consider what kinds of data you need. How are you going to access it? Like, what's the cost benefit around that? Do you have a management strategy? Really thinking about all these things beforehand is very important. Compiling data from multiple sources into a single platform. Really making the most of your project data by consolidating it as much as you can, like we've shown here with our Power BI interface. You'll notice that not all the data lives all in the same exact location. However, it's spread throughout, but it's just being able to coalesce this all together and a user interface is where we've experienced some value for project teams and clients. And again, I think we've shown kind of the different tools and techniques for these sites and how we've kind of leveraged this to engage with our client and really provide utility across our project teams and really focusing in on engagement, getting them invested in the products that we're pushing out so that we can um, get their feedback. It's a kind of the summary here. So with that, any questions?
Thank you to all our presenters, Carrie, Buffy, and Chris. That was a great presentation on all the important considerations and challenges of managing data and how to make the most out of that data. If there are any questions, anybody can enter it either in the chat or you can raise your hand and we can unmute you and you can ask it live. So there's one question that's been entered so far. It looks like these projects pull data from many different sources. Do you need to plan ahead to ensure the different data sources can work together and communicate properly? And what sort of strategies help ensure the different sources work together best?
I can address some of that. Ideally, as you're beginning a project, you would hope that you know all of the different data types that are going in, but you won't. There will be times when things will come up, or you'll want to use a different data set, or you'll find different documents that you want to link in, or the client might request that you go in a different way or add some information. So in a perfect world, you would know that everything would work together, but that is sort of the responsibility and what is included in sort of data management is making different file types and these sources work together. There are always going to be hiccups, but these sort of systems within systems that Chris highlighted make it easier than ever to share disparate data types and to be able to put them into one spot.
Okay, I see we have a question from Jim Schutz. Please unmute yourself and go ahead and ask your question.
All right, thank you. Great presentation, everyone. I really enjoyed this. A lot of good content, and it was presented very well. My question is, within the next 5 years, what do you see as one of the more profound advancements in, presenting data and the tools that you showed here? And I'll caveat that without mentioning artificial intelligence.
I'll jump in on that, Jim. Thanks. So we already are kind of seeing that, and you don't need to mention AI without the implication being right there, right? One of the things that's I really foresee being a major shift in traditional software users, especially GIS folks, is the whole concept of digitizing data. Right now, I think a lot of that involves folks actually geo-referencing stuff and clicking that, but we're already in conversations with other team members around the organization and really looking at ways that just automate this stuff, especially when it comes to things like image segmentation, that is grouping like pixels together into groupings to make sense of the data and really avoiding the need for somebody to do the photo interpretation around that. And so much of what we do, I think, involves that photo interpretation step. Is taking that data and doing the interpretation ourselves and converting that data into polygons or pixels, which by default in GIS speak just get turned into data records in a table. I think that's one of the big things that I anticipate seeing done. Those are my initial thoughts. I don't, Carrie or Buffy may see something
Yeah.
else, but yeah.
Yeah, that's where I immediately went, was with machine learning, putting more of this, having to go through pixels and pixels and just having sort of teaching the computer how to find those things that are important to you for a particular site. I worked on one project where we were teaching the software to differentiate between porous pavement and impervious pavement for a green infrastructure project. Those subtleties might not be obvious to a human user, but might be very obvious to a machine who that has learned how to pick up those differences. So I'm excited about that, Jim, and I can see that becoming much bigger.
Okay, we have a couple more questions in the chat that have been entered. Next question is the imagery swipe app something that works with any type of data?
Yeah, so the imagery swipe app, as I understand it, is meant to work with images. Although I know in a desktop environment you can swipe vector data. So truthfully, I've not tried it on a published vector data set in the ArcGIS Online environment. But I could test it out and let you know if you let me know who's asking the question.
One of the things that we're going to do for the DEC client is digitize historical Sanborn fire insurance maps. And then we will be able to compare historical land use with contemporary land cover to see if we can find any patterns of distribution to help develop perhaps sampling plans based on the historical use of the property.
Okay, we'll go to the next question from Tim Ulte. What are the factors you consider when deciding between comparable solutions or apps like ArcGIS field maps versus Forms on Fire or Power BI versus Esri dashboards?
Yeah, that's a good question, Tim. And you know that coming from a GIS background that's so Esri specific, we tend to gravitate towards those solutions first. A few things with the mobile collection platform, Forms on Fire, I know is preferred in a lot of cases because you don't have to have connectivity, internet connectivity. You can do a forced sync if you're out of cell range or outside of a network. And then there's also a lot more logic that can be built into Forms on Fire with cascading, cascading data collection choices and such. And we have a team of people who have so much experience with this. Other thing about Forms on Fire is the ability for it to push the form data directly to a SQL database or really any database platform, which renders it available directly through other systems, with API connectivity to that data. And in this instance, the choice of the Power BI as the platform, because we had so many other data sources that we needed to connect to, and we have Taylor, who is really well versed in this. We chose this as the platform to go with. And the second part to that answer is I don't know what what ArcGIS's uh, online offering is for dashboarding when it comes to connectivity to these other data platforms that's built inside of Power BI. So probably a little bit of ignorance on my part with that as well. But That's the why there.
Okay, I see we have one more question, then we might call it a wrap if there's no more questions after that. So from Peter De Silva, what are the limitations of collecting location data from Forms on Fire and their associated devices?
I can jump in. Oh,
Yeah,
go ahead, Chris.
please do.
Okay.
Thank you.
Okay, it depends on how strong your cell network is. Some areas with a lot of cell towers, you can get pretty good location data, but we actually, if we have a critical need for sub-meter accuracy, we will typically pair it with a USB connected GIS or GPS device rather, so we can get sub-meter accuracy. We're not going to get to sub-foot accuracy with a general tablet. We would need to move it to an actual GPS receiver at that point.
Okay, I think we can move on to the next slide. If anyone else has any other questions after the webinar, please feel free to reach out to our presenters and they can hopefully help answer your question. A link to the form for the PDH credit has been posted a couple times in the chat throughout the webinar. If you have any issues downloading that form and want to get that credit, please let us know. And if you missed any of the questions, the recording of the webinar will be posted up on our channel in the next few days to a week. If you want to review it or go back and reference anything in there. So our next webinar will be on April 10th on artificial intelligence, fueling the new era of growth. It will be presented by Guada Casuso and Alyssa Douglas at the same time as today's webinar at 12:30 to 1:30 p.m. Eastern. So thank you to everybody who joined us for today's webinar, and we really hope to see you again in April.